Welcome to the fifth part of VCAA Specialist Maths 2021 exam papers. In this video, we will solve exam paper 2, section A, questions 6 to 10. Statistically, most students answered question 10 well. However, most students had problems with the rest of the questions, particularly the antiderivative of the expression in question 9.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA Specialist Maths exam paper series. This is section A of 2021 exam 2 paper. There are total 20 multiple choice questions in section A and 6 extended response questions in section B. In this video, we will present questions 6 to 10 in section A. As it can be seen in question 6, z is a non-zero complex number, but z squared is a real number. The question here is to find the possible values of argument z from the following 5 expressions. Since z squared is a real number, it can be written to a times cis of k pi, where a is a positive real number. According to the Marlborough theorem, z equals square root of a times cis of k pi over 2, in which argument z equals k pi over 2, where k is an integer. So the answer for question 6 is A. In question 7, a relation is defined parametrically by x of t equals 5 cosine t plus 1 and y of t equals 5 sine t minus 1. Here both a and b are 2 points that lie on the graph of the relation, and their coordinates are 6, -1 and 1, 4 respectively. The question here is to find the shortest distance along the graph from a to b from 5 given choices. Based on the parametrically defined relations, cosine 2t equals x minus 1 all over 5, and sine 2t equals y plus 1 all over 5. According to the Pythagorean identity, the square of cosine 2t plus the square of sine 2t equals 1. It follows that x minus 1 all over 5, or in parentheses squared, plus y plus 1 all over 5, or in parentheses squared, equals 1, which gives x minus 1 or in parentheses squared plus y plus 1 or in parentheses squared equals 25. Hence the relation is a circle centered at 1, -1. According to the coordinates of the points A and B, it follows that the shortest distance between them along the graph is a quarter of the circumference of the circle. It equals 1 over 4 times 2 pi r, which equals 5 pi over 2. So the answer for question 7 is E. Question 8 is to use Euler's method to find the y value when x equals 1.2 with a step size of 0.1, given that when x equals 1, y equals 2. According to Euler's method, its first order process is written to y sub n plus 1 equals y sub n plus y prime sub n times h. Here we have x sub naught equals 1, y sub naught equals 2, and h equals 0.1. Hence, the first step of approximation can be written to y sub 1 equals y sub naught plus y prime sub naught times h. After the values of x sub naught, y sub naught, and h being substituted, the value of y sub 1 equals 2 plus 2 times sine of 1 times 0.1, which equals 2.168. The next step is to calculate y sub 2, which is written to y sub 1 plus y prime sub 1 times h, which equals 2.168 plus 2.168 times sine of 1.1 times 0.1, which equals 2.3615. So the answer for question 8 is C. Question 9 is to determine which of the 5 given derivatives corresponding to a graph f of x has no point of inflation. Based on the definition of point of inflation, it occurs where the sign of its second derivative changes from negative to positive or vice versa. To explain this, the graphs of illustrating different situations for different functions are shown at below, where it can be seen that a graph has point of inflation when its second derivative equals 0, while its first derivative is either greater than 0 or less than 0. Here we continue to work on question 9 by checking all the 5 given derivatives. As for A, since its second derivative equals 4 times x minus 3, or in parentheses, which change sign after passing the point x equals 3. So the function has point of inflation at x equals 3. For B, since its second derivative equals 6 times x minus 3, or in parentheses squared, which is greater than or equal to 0, the second derivative of the function doesn't change sign at any point in this case, so the function curve has no point of inflation. For C, since the second derivative equals 5 times x minus 3, or in parentheses, obviously it changes sign after passing the point x equals 3, so the function has a point of inflation. For D, since f double prime of x equals x minus 3, the second derivative changes sign after passing the point x equals 3, so the function has a point of inflation. For E, since f double prime of x equals 3 times x minus 3, or in parentheses squared, then minus 12, which can be written to 3 times x minus 3, or in parentheses times x minus 5, or in parentheses. So it has 2 points of inflation at x equals 3 and x equals 5. In conclusion, the answer for question 9 is B. In question 10, it shows the diagram of direction field of a differential equation. Based on that, it requires identifying the correct differential equation among the 5 given ones. According to the given direction field, what we need to do is to pick up a few points that help to identify the corresponding differential equation. Here the points being picked up for evaluation are 1, 1, 0, 1, negative 1, 1, and negative 1, 0. And accordingly, the approximate values for the slope at point 1, 1 equals negative 1. The slope equals negative 2 at point 0, 1. The slope equals 3 at point negative 1, 1. And it equals 2 at point negative 1, 0. As it can be seen that the slope at these points satisfy the differential equation dy by dx equals y minus 2x. So the answer for question 10 is D.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.